Okay, we're going to go ahead and finish the notes from 5.1 and then we'll start 5.2 notes. Homework is then going to be a Google form. By the end of class, you should be able to state the number of solutions of a system using the graphing or the substitution method. That's your goal. So first we have these two lines and we want to graph them and see how many solutions does the system actually have. Go ahead and the first thing that you should be trying to do right now is getting each equation into that y equals mx plus b format so that you can go ahead and easily graph them. Okay, so starting off with this first equation, I'll put it in red. I have 2x plus 4y is equal to 6. I'm going to first start off by subtracting 2x from both sides, because remember my goal is to get y by itself. These 2x is positive, so the opposite's negative. And that gives me 4y is equal to, and because I want to keep it in mx plus b format, I have this negative 2x and the 6. Obviously, I can't combine them because one has an x variable, the other does not. So I'm going to put my x's first to keep the format, negative 2x. This 6 is positive, so plus 6. And then my last step, I'm going to divide everything by 4 to isolate my y. These 4's cancel out, and I have y is equal to negative 2 over 4. I can simplify that to negative 1/2 because they're both divisible by 2. X, and then 6 over 4, I can simplify that to 3 over 2. I am, since we're going to graph it though, going to make this value a decimal just to make it a little easier to graph. Well, to understand when I graph how I'm getting my numbers. And then plus 1.5. So I'm going to start at 1.5, which is halfway between 1 and 2. I'm going to make my point about there. And then I have my slope of negative 1/2. Remember, negative 1 means we're going to move down 1. The 2 is positive, so to the right 2. So I'm going to move down 1, to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And sorry, it's a little bit off. I'm trying to use this app. Okay, and then I could do taking the slope in the opposite direction to complete my line. So now I can go up 1 to the left 2, up 1 to the left 2, and then I would connect my points to create my line. So that is my first equation. Now for the second equation, negative 4x plus 2y is equal to negative 2. I can go ahead and again, my goal is to isolate y so we can get it into this format of the slope-intercept form. So I'm going to add 4x to both sides. And those 4x's and negative 4x is going to cancel out. I'm left with 2y is equal to, and again, I can't combine these terms. I want to make my term with my x go first just to stay in format. 4x minus 2. My last step, I'm going to divide everything by 2. And I'm left with y is equal to 2x minus 1. So my first point is going to be at negative 1. And then from there, this 2, I'm just going to put the 1 in the denominator so that I could show that I'm going to be moving up 2 units to the right 1 unit. Up 2 to the right 1. 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 And then I can take it in the opposite direction, down 2 to the left 1. Down 2 to the left 1, and so on and so forth. I would then connect my blue points to make my line with the arrows at the end. If I could make the line, unfortunately, with this program, I don't have the ability to make a straight line. But if I could, for the red and the blue line, we would see that they actually intersect perfectly at one point. So there is one solution. I'm going to write SOL and shorthand for solution. And they actually would intersect perfectly at this point here, 1, 1. So I would say my solution is 1, 1. So we've solved the system using the graphing method. Okay, that was the last example for graphing. Now we're going to look at, and as always, here is the solution along with the digital version of the graph. And here it's easy to see how the 2 points intersected at 1, 1. So now we're going to solve by substitution. Go ahead and fill in the blanks on your notes with the steps. Take a minute to read it. It can be a little confusing, I know, just reading the steps written out, but it should hopefully be a little bit easier to understand once we actually do the practice problem right now. Okay, so first things first, we have 2 equations. I just went ahead and labeled the first one as equation 1, the second one as equation 2. The first thing I want to do is choose an equation. So I'm choosing my equation number 1, y equals negative 2x minus 9. And I'm going to take that equation and I'm going to plug it into my second equation. What that means is that in this second equation, anytime I see the letter y, the variable y, I'm now going to replace it with that entire equation, negative 2x minus 9. So I'm going to take this and I'm going to substitute it back in for my y value in my second equation. So I have 6x minus 5y equals 19. But now again, wherever I see the letter y, I'm going to be replacing it with negative 2x minus 9. So that's going to become 6x minus 5. And again, now instead of writing y, I'm writing negative 2x minus 9 is equal to negative 19. First step, now that I have it where I just have one variable being used in the entire equation, I can use algebra to just isolate my x and figure out what its actual value is. So first step here, I'm going to distribute this negative 5 to my terms inside my parentheses. So that's going to become positive because negative 5 plus times negative 2 is going to give us positive 10x. And then negative 5 times negative 9 is positive 45. I still have in the front there the 6x, so I'm going to just place that back into the front. And then that is all equal to negative 19. On the left-hand side, I can combine these two terms because they're both values of x. And so 6 and 10 is going to give me 16. X plus 45 is equal to negative 19. And then I can go ahead and I'm going to subtract 45 from both sides. Because remember, my goal is to isolate my x. The 45 and negative 45 cancel each other out. I'm left with 16x is equal to negative 64. Because negative 19 minus 45 is going to give us negative 64. The last step, I'm going to go ahead and divide both sides by 16. Because again, I'm trying to isolate my x. The 16s cancel each other out, and I am left with x is equal to negative 64 divided by 16 is negative 4. So I now have that first step and second step really completed. And now I know what the value of x is. It's negative 4. But remember, we're looking for a point. And a point's not just one, but you need to list 2 numbers for your coordinates for the point. So great, we've solved for our x, but we're still missing our y value. But now that we've solved for x, we can go ahead and we can take that value of x and substitute it back into either of the two equations, doesn't matter, equation 1 or equation 2, and be able to solve for our y. I'm going to go ahead and I'm going to plug it into equation number 2. Or sorry, I'm going to go ahead and plug it into equation number 1, just because for me it'll be easier. But either one that you choose will work out. Our algebra throughout will just look different, but our final solution should come out to be the same. Again, there's the steps for how I just solved for x for that one. And now that we know x, see how I'm plugging it back into equation number 1. Y equals negative 2x minus 9. So now I'm taking this equation, and I already know that x is equal to negative 4. So now anywhere where I see the letter x, the variable x, I'm going to replace it with the negative 4. So now I have y is equal to negative 2 times negative 4, because again, I know x is equal to negative 4, minus 9. So y is equal to negative 2 times negative 4 is 8, minus 9. Y is equal to 8 minus 9 is negative 1. And now I know my y. That means I can state my final solution is negative 4, comma, negative 1. Those are my coordinates. Remember, your x value always comes before the y value when listing your coordinates of your point. So my final solution is negative 4, negative 1. And this problem had one solution. So now seeing how I just solved that one, go ahead and I'm going to clear this out. And there's the solution again. Go ahead and solve this problem. First, I'll tell you for step 1, x equals 6y minus 7. So I'm choosing to plug in equation number 1 into equation number 2. When you do that, what do you get as your value of y? Okay, so taking that first step, I'm going to go ahead and again, anywhere now, here it says x is equal to 6y minus 7. That means when I'm using the second equation, 4x plus y is equal to negative 3. Now, anywhere where I see an x, I should be replacing it with 6y minus 7. That's going to give me 4x. Sorry, let me erase that. That's going to give me 4. And then now instead of writing x, remember I'm replacing that with 6y minus 7. And then plus y is equal to negative 3. I'm going to take this 4 and again distribute it to what's in my parentheses. So 4 times 6 is going to give me 24y. And then 4 times negative 7 is going to give me negative 28 plus y, because I still have this plus y from outside of my parentheses, is equal to negative 3. And really quickly, I'm just going to rewrite that plus sign because it looks a little bit like a 7. Okay, and again, notice here on the left-hand side, we can combine these two like terms, and that's going to give us 25y minus 28 is equal to negative 3. I'm going to add 28 to both sides because my goal is to isolate y. And that's going to give me that 25y is equal to 25. My very last step, I'm going to divide both sides by 25. By dividing both sides by 25, the 25s cancel each other out, And I'm left with y is equal to 25 divided by 25 is 1. So again, from my coordinates, I need to know my x and my y. Right now, I've just solved for my y. I know y equals 1. I still don't know quite yet what x equals. But now that I know what y equals, again, I can go ahead and plug it back into either of the two equations that I want. Doesn't matter which one you choose, as long as everyone does the algebra correctly. We should still come up with the same solution, regardless of choosing equation 1 or equation 2 to substitute back in your value of y. So I'm just going to go ahead, and there's the algebra again. And I'm going to plug it back into equation number 1. Okay, so go ahead and do the same right now. When you plug in y equals 1 back into equation number 1, what do you get as your x value? And then what do you get as your final coordinates? So plugging back in what we know, we have x is equal to 6 times, I know what my y is, it's 1, minus 7. So x is equal to 6 times 1 is 6 minus 7. So x is equal to 6 minus 7 is negative 1. Be very careful when you're adding and subtracting with your integers. Remember, you can always use a calculator. You're allowed to. And then now we can state our final coordinates. Remember, x always comes before y. So my final coordinates are negative 1, comma 1. And that means, because we had coordinates of a point, that this problem had one solution. Again, SOLN for short for solution. Go ahead now that you are done with this Edpuzzle. Make sure that you go ahead and do the Google form that's set for homework.